the A part in my previous video. In the B part, the question is asking find the values of GM1 and RO for all transistors. So when they say GM1, that is for the transconductance of the Q1. So in order to calculate the transconductance, you have to just put it in the transconductance equation that's given by GM1 is equal to square root of 2 Kn prime W over L times the ID1. So in this case, 2 Kn prime W over L is provided in the question. That is 4 milliampere per voltage square. So this is 4 milli right here. And then ID1 is 100 microampere. 100 micro, like if you wonder how did we get the ID1, it's in the A part of the question. Since it is matched, the current is equal everywhere. So whatever the currents we have here, that's the exact same current we are going to have for the ID2 and ID1 as well. Okay, so from that one we can just plug it in and find the value. So this is here we have 2 times 4 8 times 100 800 milli and micro, that's going to become a nano. And if we simplify this one, hundred micro 2 times 8 milli, so the answer comes out to be 0.89 milliampere per voltage square. Milliampere per voltage. Okay, and if they ask you to find, this is for the GM1, but in the question it says just GM1, but they are also saying find the values of GM1 and RO for all the transistors. So maybe it's let's say if it's GM and find for all transistors, then you have to calculate the GM2 and then GM3 as well. For GM1 and GM2, the difference is, if you look at the circuit, the GM1 is a NMOS transistor and this Q2 is a PMOS, Q3 also PMOS. So these two are PMOS transistor. This is a NMOS transistor. How do we know? Because of the arrow pointing inward. If it's arrow pointing inward, that's a PMOS. If arrow pointing outward, that's a NMOS. So here these two are PMOS. So the transconductor equation is a little bit different. That is, instead of Kn prime, we will have Kp prime right here, and this is W over Ln, and this will be W over Lp. And this one current is going to be ID2. And if you look at the question, they say Kn prime W over Ln and Kp prime W over Lp, both of them are equal, and that's 4 milliampere per voltage square. And both of them are equal. At the same time, the current also equal because of the current mirror effect, because it's matched. It means the exact current is going to flow through this one as well. So it means this current also 100 microampere. So there's nothing different. This is 2 times 4 milli 100 micro, exact same thing here as well. So we supposed to get exact same answer, 0.89 milliampere per voltage. GM3 same thing, 0.89 milliampere per voltage. Okay, now the next thing is they're asking us to find out the output resistance RO, that is given here. Find the output resistance. RO is nothing but the early voltage VA prime times the length divided by the ID current. Now here, if you notice, we have VA, we don't have the VA prime, we have VA, we don't have the length provided, and ID current is known, that is 100 microampere. But you have to know one thing, that is VA is nothing but VA prime times L. So instead of VA prime L, we can replace it. We can also write this one as RO is equal to VA divided by ID as well. Okay, and VA is 20 voltage divided by ID, that's 100 micro. So 20 over 100, that's 1 over 5, 0.5 micro become mega, and when it goes on the top, and mega multiplied by 1000 become a kilo. So 1 over 5 is 0.2. Yeah, 0.2 multiplied by 1000, that is 200 kilo ohm resistance. And the output resistance is going to be exactly the same for, so if I say this is RO1, this is ID1, if I plug this one, so and this one also going to be equal to RO1 is going to be equal to RO2 because exact same current, exact same VA, and RO3 also exact same thing because exact same current, exact same VA. Okay, because they say all the transistor has VA of 20 voltage, so it means the currents also same, VA is same, so the output resistance should be same. And that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.